Welcome to this special episode of Frequency Matters, the RF and Microwave Update Series. I'm Pat Hindle, and I'm here with Jokan Jelowitz, Product Line Manager of RF and Microwave for the Communications Group at Analog Devices. Welcome, Jokan.
Hey Pat, thanks for having me.
So, with Mobile World Congress coming up in Barcelona, thought it'd be great to discuss the status of 5G millimeter wave applications. So, what is the current state of 5G millimeter wave deployments?
Right, I think it's a good, relevant question. And over the last few years, it has become increasingly clear that large-scale mobile deployments of 5G millimeter wave aren't materializing as quickly as we expected or we imagined. And instead, what we are seeing today is that most activity in traditional millimeter wave spectrum is happening around fixed wireless access or FWA. These deployments essentially are delivering high-speed broadband to homes and buildings and enterprise sites. And in many cases, if you imagine that they're competing against directly with cable and fiber and satellite networks. And of course, over the years, and this fixed wireless access has become a really valuable tool for the operators and giving them access to a broader customer base. And especially in the United States, you can see the fixed wireless access has emerged as a meaningful revenue driver, as you can see. And as far as I can track, of course, is playing a major role in shaping operator strategies and helping them expand their customer base and customer reach.
And so you mentioned fixed wireless access as a dominant deployment scenario for 5G millimeter wave spectrum today. Can you mention some of the trends and technology advances in FWA deployments?
Absolutely. Yeah. Now that the fixed wireless access has clearly emerged as the leading use case for 5G millimeter wave, and we can see the technology evolve in ways that are much more tailored to those fixed wireless access deployments. And if you can imagine, up to now, most operators have been using millimeter wave hardware and software originally designed for mobile coverage, then actually adapting it for fixed wireless access users. But of course, we can see that's starting to change, and we are beginning to see a real shift towards what we call a purpose-built millimeter wave solution, and especially when it comes to customer premises equipment or CPE. As vendors focus on more directly on the fixed wireless access, you can see the CPE side is becoming more optimized, higher performance, and much more flexible than it used to be. And we're excited because that opens up a big opportunity for the ecosystem, and CPE vendors and module makers alike can now have room to innovate and differentiate on performance, design, and introduce their capabilities. And it's a space that we're very excited, and it's becoming much more competitive and much more interesting as the technology matures.
And so what are some of the other application areas for 5G millimeter wave spectrum?
Right. Outside of fixed wireless access, we are seeing momentum in specific private networks where millimeter wave can actually make a meaningful difference. And these are like things like industrial facilities or large enterprise campuses. And of course, combination of ultra low latency and extremely high throughput can be truly transformative. And these are the deployments where millimeter wave strengths really shine, as you can imagine. And I'll also highlight another area that's getting a lot of attention globally. That's integrated sensing and communications. As you can imagine, ASAC and operators, vendors, and research institutions have been demonstrating the capability of ISAC over the last few years. And now it's adding an entirely new layer of opportunity, entirely new layer of value, added value for the traditional wireless networks. And of course, this idea behind Isaac is very simple but very powerful, and using the existing communication wireless infrastructure, not just for communication but also for sensing the environment. I think that means you can now detect objects like vehicles and drones and even smaller items. And of course, as you move in the frequency in the millimeter wave, and able to sense smaller objects becomes much more feasible. And Isaac opens the door to some fascinating new use cases, and we are working with our partners and customers to explore and enable these capabilities.
Yeah, we're following ISAC very closely in our area too, seeing what the new developments are. A lot of technologies for 5G, and hopefully will continue in 6G. So,
Right.
how does ADI help their customers in the new era of 5G millimeter wave deployments?
Yes, at ADI, I mean, our focus has always been about on helping customers navigate this shift in the 5G millimeter wave by giving them the technological foundation, the parts, so that they can actually innovate with confidence. And what we are seeing today is that industry's priorities are changing. Fixed wireless access, private networks, and ISAC. And these all demand solutions that are different than what mobility use case would demand, and they're more integrated, more power efficient, and easier to deploy in a way. Of course, in our role in this whole ecosystem is to make customers' journeys simpler, and we bring deep expertise in millimeter wave and mixed signal and system integration. And of course, we work with our customers side by side and optimize their performance across the entire signal chain, not just the millimeter wave. And of course, we provide everything from the highly integrated millimeter wave beamforming ICs, as well as reference design and all the system level support that goes with it and accelerate their development cycles. With this being said, we actually IDEA has released, completed the release of its third generation of 5G millimeter wave, and the family covers the entire of the 5G millimeter wave, 24 to 40 gig. And our portfolio includes up and down converters, beamformers, and up and down converter plus beamformer in a single chip. Just to give you an example, ADI is ADMV 48281 and ADMV 49281. These are the beamformers, and they boost industry's highest efficiency with 16 channels, highest integration as well. In addition, our third generation family allows ease of routing and ease of antenna calibration for high channel count phase arrays. Considering the higher integration needs for the CPEs, we also introduced ADMV 1228. It's a chip that actually incorporates 2 by 8 channel beamformers with up and down converters. So we can see the need, we can see the demand, so we're just acting accordingly.
Well, thank you, Yokan, so much for talking with me today about the 5G millimeter wave applications. I know Analog Devices is providing some great products here.
Yes, thanks for the opportunity, Pat. Thank you.
Great. And to our audience, you can find more videos at videos.microwavejournal.com. Thanks for watching.